So in the second part of this unit, we're going to see how we can find out what is inside the data frame, how we can examine what's there. So we're going to start by exploring what you can do with Pandas by creating a data frame with some information about Marvel superheroes and villains. So this is a set of data that I discovered on the internet, and it's going to create a set of values. So the first thing we want to go and do then obviously is display the data frame. So in this example we've made a list of dictionaries and the data we're going to work with. Each key in each dictionary is used to identify the column, and each dictionary represents a single row. In a notebook, such we're using to make these slides with, then we get a nice tabular display of the data frame. And so you can see here the columns, those were the keys I had in the dictionary, and then the values and all the data. Now, this data frame is really very small. We've just got 12 rows, so it fits all on the screen. If it was much bigger, say several million rows, we'd not want to go and just display the whole thing. We'd be sitting there waiting for the computer to finish making a nice table of a million rows, which we then can't really look at. But it can be useful to check what's in the first few rows or what's in the last few rows. And to do this, we can use the head method, so df, that's our data frame, dot head, and then I can tell it the number of rows I want to see. In this case, I'm just looking at 3 rows. And to look at the last few rows, I can use dot tail, and again tell it how many rows I want to look at. We probably want to have some more detailed information, and again, if you've loaded up a data frame with a million rows, it can be quite useful to try and get some idea of what's in there. And so what we can do is we can use the dataframe.info, and that goes and tells us a bunch of information about what the data in the data frame is. So it tells us the names of the columns, it tells us how many non-null values we have in there. In this case we've got 12 values in each column, and it tells us the data type, the D type of each column. So that's telling us whether it's an integer or an object. Basically means a string. An object is a kind of a catch-all for everything that's not otherwise a number or a Boolean value or a time or a date. And so it also tells us how much memory this is taking up as well. And that can be a real consideration. And there are other Python libraries which can be designed for when you're dealing with data sets which are so large that they can't fit in your computer's memory conveniently. Where we have a data set with numerical values in it, then Pandas also provides us a way to get some statistical information about those numbers. And again, this can be useful to get a feel for what's actually in your data set. And that's done with the df.describe method. And so that looks for each of the columns which has got a numerical data type. So that's, in our case, it's these scores. And you can see it's giving us a count of how many values we have, but also the mean value, the standard deviation, and information about the distribution of values, so the minimum, the maximum, and then also the quartile information. So what's the value at the 50% quartile will be the same as the median. I mean, that's basically what median means, and then the 25th and the 75th is the first and third quartiles. So you get a feel for the shape of the distribution from this as well. We can also get some more basic information from this, much in the same way as we could with a NumPy array. So for example, we can ask it what is the shape of the data frame, and that will tell us this is a data frame with 12 rows and 8 columns. Unlike a NumPy array, where we have to use numbers to refer to the rows and columns, Pandas allows us to give each column and row a label. So by default, the columns have got string labels and the rows have got numerical labels. That doesn't need to be a number at all. So I can ask it for what columns we have, and the columns you access with the .columns attribute, And when we do that, you can see it returns a thing called a pandas index. That's basically just saying this is a set of values we're using to identify what part of the data frame we're interested in. And you can see it's given us the names of the column headers there. And the corresponding thing for the rows is called the index. So df.index. And what this is giving us something called a range index. That just means it's using a range of numbers. And you can see it's telling us it starts at 0. And just like the range command in Python, the stop value is the up until but not including value. So stop is 12 and step is 1, meaning our rows are indexed 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. So, as we were just saying, that the index is one of these other pandas data structures, and that's what the data frame columns and the data frame index is giving us. And these don't just need to be numbers. So, for example, though df.index is a range index and specifies things in numbers, the columns is a set of strings. Also, as with a NumPy array, we can ask it about the data type, the D type of the data frame. Except the difference now is that each column can have its own individual data type because the data frame itself can store more than one data type in the columns. So if we ask it for df.dtypes, plural, because there's more than one of them, then it gives us an output which tells us the column and then the corresponding data type. And as I said before, for things which are strings, they get called objects. And in this example so far, we've only got integers there, and it's worked out therefore that it can store all the numbers as int64. The 64 is just referring to the size in memory of the integer, and that therefore controls the range of the numbers you can store in it. Okay, if we want to get at the underlying values, then it's really easy to go and convert the data into a NumPy array. And that's because actually Pandas is built on top of NumPy. So in the internals of Pandas, at least when it was originally conceived, it was built on top of NumPy. Modern versions of Pandas have actually moved away from this, but they still have this very close connection with how things work in NumPy. So I can just do df.values, and that is actually giving me a NumPy array. But of course, it's a slightly complicated NumPy array because each column's got a potentially different type of D type, and that ends up meaning that in NumPy the D type is again set to this object, meaning it's not a number, it's not a nice simple value it can store. This doesn't actually make very much good use of NumPy because NumPy is not optimized for mixed data types like this. So generally speaking, we wouldn't ask it for the values if we knew that we had different data types in there, because it's simply not going to be very efficient. Notice that the described method actually returned the information as a data frame as well. So you can convert that to a NumPy array too. So df.describe told us the summary of the values, the statistics we had, and we can just do .values, and then it comes back again as an array. Only this time, because all the values were floating points, it produces a NumPy array that is a bit more sensible to work with.